Hi guys, and welcome to another video. And as promised from the last video, we're looking at grade 11 exponents and surds, simplifying expressions using the laws of exponents from past examination questions, part 4. We're simply not just answering the questions, but I'm trying to explain the concepts which are involved in the answering of the questions. Let's look at the work schedule. See, the work schedule says that under exponents and surds, we need to simplify expressions using the laws of exponents. So we are at that point now where we're simplifying using the laws of exponents, and our next aspect will be to solve equations using the laws of exponents. But we also looked at the addition, subtraction, multiplication, and division of surds as well in these series of videos. Solve simple surd equations will come in the next aspect under solving equations. And then we'll also look at equations, inequalities, and so on. So let's get back to it. If you want to look at more advanced questions as well, you can also look at the grade 12 section on algebra on jlmaths.com or also on the YouTube channel. So the first question here in the 2017 paper 1, actually it's question 2.1, is on exponents, simplifying this expression. And we got 3 to the m plus 4 minus 6 times 3 to the m plus 1 all over 7 times 3 to the m plus 2. So if we look at that particular question now, we can simplify it as follows. Normally what we do is we say 3 to the m times 3 to the 4. We write as separate terms so that we can factorize, because if you have to look at your numerator, you've got two terms in your numerator, so you have to factorize in order to simplify. So for 2.1, I'm going to write it as follows, 2.1. So if you look here, we got 3 to the m and 3 to m there, so we can actually remove that as a common factor. But let's write as separate terms. First, 3 to the m times 3 to the 4, 3 to the m times 3 to the 4, and here we have minus 6, so it'll be minus 6 times 3 to the m times 3 to the 1, so that's 3 to the m times 3 to the 1 all over 7 times 3 to the m times 3 to the 2. So here we got 7 times 3 to the m times 3 squared. In our next step, we can take out 3 to the m as a common factor, and we're left with 3 to the 4 minus 6 times 3 all over 3 to the m times 7 times 3 squared. So 3 to the m cancels with 3 to the m, and we're left with 3 to the 4 minus 6 times 3. So 3 to the 4 will equals to 81 minus 6 times 3 is 18 all over 7 times 3 squared. 3 squared is 9 times 7. 9 times 7 is 63. 81 minus 18. So that should give us 63 all over 63, which will equal to 1. So our answer here in this question is 1. So that's the first one done. In the next question that I want to look at, remember I'm only looking at the questions on simplification of exponents and surds. I will cover equations in another series of videos. So the next question I want to look at is question 2.3, which is if x equals to 3 minus the square root of a all over the square root of 2 and y is equal to 4 plus the square root of a all over the square root of 2, determine the value of x plus y all squared. So what we're going to do here is we're just going to substitute x plus y and we're going to simplify. So let's have a look at that. So 2.3 is as follows. So 2.3. So x plus y all squared, x plus y all squared is going to equal to, what's x? X is 3 minus root a over root 2. So we got 3 minus root a all over root 2. We'll put that in brackets, and that's going to be plus y. Y is 4 plus root a over root 2. So that's 4 plus root a, 4 plus root a all over root 2 squared. That's 2. So we already got a common denominator, which is root 2. So basically we have 3 minus root a plus 4 plus root a, and that's all squared. So minus root a and plus root a cancels, and we're left with 3 plus 4 is 7 all over root 2, and that's all squared. So therefore, okay, now look at it. 7 squared is 49. 49 all over square root of 2 all squared is 2. And that should do it. 49 over 2. The next question that we're going to be looking at is 2.4. And here it says, show without using a calculator that the 12th root of 10 times the 6th root of 640 times the 4th root of 810 times the square root of 40 equals 220. So if you got to show that question, we have to break it up into the left hand side equals to the right hand side. 2.4 will be as follows: 2.4. So we'll write down the left hand side equals to the 12th root of 10. So I'm going to write down the 12th root of 10 times the 6th root of 64 times 10 times the 4th root of 81 times 10 times the square root of 4 times 10, which will equals 2. So now let us see what we can get here now, right? So here will be 10 to the 1 over 12 times the 6th root of 64 should give us the following. Now remember, 64 can be written as 2 to the power 6. You can actually use your calculator for this if you want. Oh, there's it here. All right, so the 6th root of 64 equals to 2. Right, so that's going to be 2 times. And here you're going to have now the 6th root of 10, which is 10 to the 1 over 6, times the 4th root of 81. And remember that 81 can be written as 3 to the 4. So therefore, the 4th root of 3 to the 4 will leave us with 3. If you're not sure, knows and you can't find it, that's fine. We eventually got it. So the 4th root of 81 equals to 3. And there's it. And now you're going to have the 4th root of 10, which is times 10 to the 1 over 4. Right? And then square root of 4 is equal to 2. So that's times 2 times 10 to the 1 over 2. So that will be 1 over 2, 10 to the half. So let's see, what do we have here? 2 times 3 is 6. 6 times 2 is equal to 12. So we're going to have 12 times 10. And here you're going to have 1 over 12 plus 1 over 6. Remember now, you've got all the same base. So and remember, you're multiplying. So you're going to add the indices. 1 over 12 plus 1 over 6 plus 1 over 4. Plus 1 over 2. So 1 over 12 plus 1 over 6 plus 1 over 4 plus 1 over 2. And if we get an LCD here of 12, this should give us 12 times 10 to the, let's go have a look at that quickly. 1 over 12 plus 1 over 6 plus 1 over 4 plus 1 over 2. 2 equals 2. See, 10 to the, you're going to be left with 10 to the 1. Right, and then we know that the right hand side is equal to what? 120. So 12 times 10 is equal to 120. In conclusion, we can therefore write it's equal to the right hand side. Quickly, let's just look at the next question. Okay, and in this particular question here, once again, we've got 2 to the x minus 3 times 2 to the x plus 1 all over 2 to the x minus 2 equals to, see here, by now, if you watched all the videos, by now you'll be able to say, well, you know what, I don't even have to write a separate terms. I can just remove 2 to the x as a common factor because I can see it. So this will be 2 to the minus 3 times 2 to the 1 all over 2 to the x times 2 to the minus 2. Okay, so you can see that you'll be left with 2 to the minus 3 there. You'll be left with 3 times 2 to the positive 1 there. And you'll be left with 2 to the minus 2 there. So you can just double check in that way. 2 to the x cancels with 2 to the x. So what am I left with? 2 to the minus 3 is 1 over 2 cubed, which is 1 over 8 minus, and this one is 3 times 2 is equal to 6. And remember now that 6, you can write it over 1. 6 over 1, and that's 2 to the minus 2 is 1 over 4. So once again, if you wanted to, you can use your calculator at this stage let's say without a calculator, 1 over 8 minus, now 6 8s are 48, so that will be 48 over 8. 48 over 8 should give us 6, and we got 1 over 4. So therefore 1 minus 48 is minus 47, so minus 47 over 8. 1 over 4, to change division to multiplication, 1 over 4 becomes 4 over 1. So therefore we can now simplify by saying that 4 goes there 1 time, 4 goes there 2 times. Minus 47 over 2 should be our solution. The last and final one in this series of videos on exponents and surds. So let's have a look at this question, 2.3. So here we got the square root of p squared minus q squared times p plus q to the 5 over 2 all over p minus q to the half equals 2. This is difference of two squares, so we'll have the square root of p minus q, p plus q times p plus q to the 5 over 2. And here we got the rather p minus q to the half, which can be written as the square root of p minus q. Now remember that the square root of p minus q times p plus q, you can actually separate that. It can be written as follows: square root of p minus q times the square root of p plus q, p plus q, p plus q, 5 over 2, all over the square root of p minus q. So square root of p minus q and square root of p minus q cancels off. So I'm left with the following. Square root of p plus q can be written as p plus q to the half times, okay, you can write it like that, p plus q to the 5 over 2. So now that you've got common bases, p plus q and p plus q, you can add the indices. Half plus 5 over 2 will give me 6 over 2. 6 over 2 is 3. So therefore it's going to be p plus 2 all cubed. And that's my solution. That is, if you haven't subscribed already, subscribe to JL Maths, like my Facebook page, Justin Lazarus Mathematics. Don't forget that all videos on jlmaths.com is in order of the work schedule. And I'll catch you in the next video.